Grade 11 identities. So there are two fundamental identities that you must know. The first one is the square identity. Sine squared theta plus cos squared theta is equals to 1. The second one is tan theta is equals to sine theta over cos theta. Then from the square identity, we can make a cos squared theta to be the subject of the formula by writing this as a cos squared theta equals to 1 minus a sine squared theta. Then we can make a sine squared theta to be the subject of the formula. Then this would be sine squared theta equals to 1 minus cos squared theta. And this one, it is called the square identity. So therefore, to simplify the expressions and to prove the identities, we are going to use these two fundamentals identities. So let us check our first example. For our first example, we are given sine square x plus sine square x cos x over 1 plus cos x, right? So let us try and simplify this, right? So in simplifying this, firstly we must read this with an understanding. It is sine square x plus sine square x cos x. So therefore we have two terms, right? This is our first term, sine square x plus sine square x cos x. And if you check, they are separated by a plus sign. So therefore we have two terms on the numerator. So between these two terms, there is a common factor of sine square x. So if you can see that there is a common factor of sine x, you can always write that as sine x times sine x plus sine x times sine x cos x. Then you will see that the highest common factor, it is sine square x, right? Maybe let us indicate this here. We have sine, it is sine square x, and on this side again we have sine square x. So therefore sine square x is our highest common factor. Alright, so if we divide the first term by sine square x, we are going to be left with 1. Plus, if we divide the second term by sine square x, we are going to be left with cos x all over 1 plus cos x. And this factor can divide this factor. So we are left with sine square x as our answer. Alright, let us move to the second example. For our second example, let us take 1 minus sine squared theta into 1 plus tan squared theta. Alright, so this can be expressed as 1 minus sine squared theta. Then if you check, if you can look carefully, we have tan squared theta, and tan squared theta, it can be expressed as sine squared theta over cos squared theta from the square identity. And if I check on this side, we have 1 minus sine squared theta, which is equals to cos squared theta, right? From here, 1 minus sine squared theta is equals to cos squared theta. Alright, then on the second bracket, we can simplify by finding the common denominator. Alright, by finding the common denominator. So this will be cos squared theta divided by 1, which is cos squared theta, times 1, the answer is cos squared theta, plus cos squared theta divided by cos squared theta, the answer is 1. 1 times sine squared theta, the answer is sine squared theta. Alright, so if you check, now we have cos squared theta over 1, right, into cos squared theta plus cos squared theta. Alright, so this is cos squared theta into, then if you check here, we have cos squared theta plus sine squared theta, which is the square identity, which is equals to 1. So this is 1 over cos squared theta. Alright, so cos squared theta will divide cos squared theta, then our answer is equals to 1. Alright, maybe let us take one last example. Our next example is going to be an identity where you are required to prove. Right, let us say maybe you are given sine square x plus sine x cos x over tan x is equals to 1. Right, so we need to simplify the left hand side to be equals to 1. Right, so this can be written as sine square x. This can be written as sine square x plus sine x cos x. Then we write this as divided by tan x, which is sine x over cos x. Right, so let us continue. So this is sine square x plus sine x cos x times, right, then we do a reciprocal. Alright, so this will be cos x over sine x. Alright, let us continue here with our example. I have run out of space, so this can be simplified further to sine squared x plus, right, plus sine x cos x over sine x. So therefore from here sine x will divide sine x. Right, so this is sine square x plus cos x times cos x. Cos x times cos x will give us cos squared x, which is equals to 1. Alright. So let me repeat this just for the sake of reinforcement. So we have at the left hand side and at the right hand side. Usually you must take the more complicated side and simplify it. So in this case, on the right hand side we have 1. There is nothing that we can really do to simplify 1, so we choose at the left hand side. So the left hand side was given as sine square x plus sine x cos x over tan x. So our first step, it is to write this as sine square x plus sine x cos x. Then we used the division sign, so it is divided by sine x over cos x. And remember that a tan of x is equals to sine x over cos x. So for our next step, it is sine square x plus sine x cos x. Then we did a reciprocal, alright, where the numerator becomes the denominator and vice versa. So now we have cos x over sine x. If you check, cos x can be divided by cos x. Now here we are left with cos x multiplied by cos x. Then we continued here. So now we have sine square x plus cos square x, which is a square identity that is equals to 1. Thank you.